to chapter 2's number 4 subchapter to do the plotting graph with formulas. There's two topics within this video. We do the first one is to draw a line like I showed here with the different dots and show the Newton's law of universal gravitation. So this is just one sample formula or the method we choose from this book. If you learned this capable way, then you can do the similar plotting as long as you have one input and generate one output in the two paired the numbers. You can draw that in this two-dimension space. So let's move this because before this subchapter, we just draw some the lines based on the given list of the number. Either these are the simple number or some number are those the temperature. But all the numbers are known number. But for the formula, the difference is we are giving one formula, and there's formulas. We have those inputs and outputs relationship. For example, this universal gravitation law have this formula shape or the format. Is described as the two body of mass m1 and m2. They are attracted each other with the amount of force F. So F is the result. M1 and M2 are the two given the data, and R is another given data. R is the distance between the two bodies. Actually, these are not the very accurate way. The distance is between the center of these two three-dimensional bodies. And the G is a constant, is the gravitational constant. We want to see what happened to the force as the distance between the two bodies increase. So that is the target we want to put. And for the mass, we have some inputs. One is the 0.5 and another is 1.5 kilogram. The value of this constant is given. Now we are ready to calculate the gravitational force between these two bodies at 19 different distance. So 115, 150, 200, 250, and you can adjust that as long as you know how you can make that into the plot. So let's do this line by line in our chapter 2. So we create now is 2.4. So let me create our part. 0.04 is let's make this 0.1. So is the universal gravitation.py. Then we can copy those ones. So those are our header. So this purpose. What are the purpose? Is the relationship between two factors, two major factors, gravitational force and the distance between two bodies. The mass of these two bodies are given, so we can see that are known the values. And then let's see what we are going to draw. So first is we import. So learned from last video is we can make our typing short. So we import matplotlib.py plot and give up our alias as a PLT. So then we have enough things whenever we want to have the those plot, or use a PLT dot plot. When we want to show, we use the PLT dot show. So those are the two part, the import part, and then this we need to think about how we can implement the formula. So the formula is we will create or define a function. So that is the draw the graph function. So we will have a def draw graph. So the input is for the graph drawing. It's just the x and y. So we put that as a generic one. So whenever we want to draw, we just load this function and make that draw. So using the functions or the skills we already learned when use this plot thing is we can say plot. PLT plot is with the given x in the x cell and y in y-axis, and give a marker. If you don't like this dot, you can use any others. So let's keep using this dot. And then since we just load all the PY plot, we don't need to load those separately. So we can give the label x-axis label. We see that is the distance in meters. And then we give the y label is the gravitational force in Newton, the unit. And then we give the title gravitational force and distance. And this we don't need our legend because we only have one line. But if you think the legend is necessary, then just give that. You can run this now, but there's nothing because you don't have our primary. The code is not load that. So let's first run make this if mean and name. Check is that is equal or not with min. So that is our standard templates. Then we will have the generate FR. So FR. So F is the force, R is the distance. So we will create that, and then this this code will start to load that. Now we define our formula, the functions. Generate FR. So it's also no inputs. So if it is that, then we have generate FR. Let's see why here is the yeah, because we have nothing put inside. So then we have something. Let's see. So first is a generate value for R. Second is a generate give the constant. So to my hope, the practice my preferred is if there's any constant, the value, put that first. So let's give this constant G. So let's give this G. Normally you use a capital letter for the constant, the value. So we already know that is this value. So it's in the scientific, there is a naming standard. So let's see. So we have this 6.674 times 10 with the power. Power is the higher the priority, so you don't need another this parentheses. So that is this one. Then we give another inputs, two masses. We give M1 is 0.5, M2 is 1.5. Or you can later on we can adjust this to the inputs. Then you can have a user to control those lines. Now we can generate a value for R. So then is after those constant or predefined value, we starting to do those variable things. So values for R is the distance between M1 and M2. So R, we define that is give a range. So when you see a range is an integer. So 100, we want to say 100, 200, 150, 200, 250. So we give this to the 1000, but we give one more to the last index. So 1000 plus 1. Then the step is 50. Then you get this list. And we have our force. So empty list to store the calculate values of f. We learned this from the list and the tuples chapter. Is if you don't have the decided value for our list, you can create our empty list first. Then is every new values you use the append method to put into or push into this list. So now is we can starting to do the calculation. Calculate force and add it to the list F. So now is we will use our loop. So for distance in R already defined as this one. So if you want to have a more closer, then we can adjust the steps. So let's use the this same the parameters from the book. So force. Now we can use the formula. Formula is G times M1 times M2 and divided by distance with square distance, and then we will append force into list F. So that's all, and we just need to last within this generate. We have our list of the R, and we have a list of F. They have the one-to-one mapping pair, so we can use this list of the pair to call the drawing drawing feature function. So now, before we leave this generate FR, we call the draw graph. Actually, this draw graph is quite standardized. Just you need to change those title, label, then you can use that in any other the plotting program. But now we call this function, so it's very easy. So draw this, and we give x, give y. So they only need this 2. So x is the let's see, x is r, y is f. So that is. So let's make those. So you can see here, as we noticed from the previously the chapter. So there's a newer version. The library, they don't have this first the dot in this axis. So it's not like the I suppose this are old version, more than 10 years around, or nearly 10 years, but now it looks better. But the key thing is we have a correct title, these labels, and for this, the step is until the every 50 we have one step, and now we can start to adjust. So if you have that, I want to see the more dots. I will do this. Then you can see it's every 10 they have the adjust. So that is the thing is we can have this way. So that is the generate FR. So if we see here is if we want to put the different the M. So let's make that to our another one. So makes certain those variables are in the different values. So the adjustable. Add variable for adjustable. It's so I want to change the M. So now is I can put this M1, M2. And then this is the M1, M2. So I want to get that from the inputs. So generate here. So let's see. So M1 is the float. And inputs, please input first body's mass, kg. So, and then M2 equal to this one. So let's make that. But you can see here is a highlight that is not the English the comma. So the second. So now I get M1, M2. I put this M1, M2, and then those I don't need to give any the definition. So this M1, M2 is read from here. So then is if I input 0.5, 1.5, it should be same. But if I change that, so let's see. So if I change this, make that the bigger. So it's one is 5.0. Secondly is the maybe the 3.7. So let's see what I draw. So it's not big difference you can see here. So and then this we have see what are the another let's see these are 5. So we change this the mass, but you can see the trends is still the not the big difference. So because they just define this by your those the excels. So starting from the 100 to the 1000. So if I run this again, so if I put that bigger 100 kilo, and that is 500, 1000 to 500, you can see that is getting the kind of similar. So which means is for this floating, you don't get that are big difference, but the value itself definitely will be different because here the trend for this curve is similar, but you can see the value now is maximum is 3.5, and this one is 6. So which means is if I generate difference, so if I do draw this one, so it's use this show. So maybe as I put this the second, and then I will generate another one. So maybe it's generate F R. So I just use this 0.5, 1.5, and the last is I will do show here. So PLT, because we only need one show. So let's see. So what will be finished? So if I put is I already have 0.515. So let me see is I have maybe it's 100, 200. So you see, if we put two lines in the same plot, then now you can see the comparison. So because these are if the mass is increased too big, is you are not get that the easier. So let's see. So if I putting not input. So let's see. I have another change. Is let's give our loop. So if for I in range, maybe I put that is 1, 10. So then I will do those I minus 0.5, I plus 0.5. So the first will be the 0.5 or 1.5, but the second will be 1.5 or 2.5. So let's see. So I will have 10 lines. What's that looks like? Generate this. So every time I will generate this one. Oh yeah, so sorry, it's put that 11. Yeah, you can see. So, but I don't have our legend. So let's no matter. But you know the top one is the this one. So and then the second one is the this second step. Then through this the mass is increase. Then this the line is decrease, the difference. So this way, for this adjustable, I try to change certain parameters so that you can get this the easier way so to do that. And then this if I put whether is I can have the legend, legend, it will be the one I think. Legend. Whether I can transfer that, that will be the not too much relevant. So I will stop this video here. So you get two the program. First program is same as the book. Second program is I put some parameters, making them in the adjustable way. You can feel free to keep modify this second one to fit in some of your own the analytical purpose. And the next video is we will put to the second the formula-based plotting is the projectile motion. So like is if you throw the stone to the sky, and this you get that this stone is like this curve, and we call this curve is our the is kind of the trajectory. So and we will adjust those different trajectory from the one standard and through the adjust some parameters like these videos we did, and we find some variable, the parameter, then we adjust that and we see the different input generate a different curve, but we can put them into the same plot. So see you in the next video, and hope you can get the needed result like me and do some practice offline. Thank you for watching.